All right, welcome to Tulsa Open Source Hardware. This is the first meeting of 2019. Woohoo! All right, so we didn't meet last month because it was Christmas, and we met the month before that, but the audio didn't pick up on the meetup, so we did not publish it. So last month, George was talking to us about a reflow oven made out of a cheap what do you call those?
Hot plate.
Yeah, cheap hot plate from like Walmart. And so he's going to give us an update on that today. Anyway, before we get started, I want to talk a little bit about Techlahoma. Techlahoma is our parent organization. Techlahoma is a nonprofit, volunteer-run organization that puts on over 30 monthly meetups, 2 annual conferences, and sponsors free local events. Okay, every meetup costs money, and we do all this to support the grassroots tech community of Oklahoma. So you can learn more at techlahoma.org and help out. You can check out all the Techlahoma meetups. Just search for Techlahoma. I think it's techlahoma.org, and it's got all the lists. There's a help wanted board. You can support us with Amazon Smile. That's where you buying Amazon gives money to Techlahoma. You can subscribe on Twitch. You can donate either one time or monthly. Apparently, there's a license plate option.
Yes.
Then you can ask your
local DMV.
Yes, talk to your local DMV to see about that. You can ask your company to sponsor us, and you can buy some merch from the store. So anyway. We're really happy because B&K Makerspace donates this space for us to meet. And so for those of you who don't know, B&K Makerspace is a great place to come, and it's kind of a workspace that's also a social space. And anyway, there's memberships available for all different levels, from just kind of you can buy a membership that just allows you to come in anytime you want, or you can actually buy physical space at the makerspace that's yours. You can store projects there, you can store equipment there, and there's all different sizes and all different levels of memberships. So anyway, B&K Makerspace, it's what's the website? BK-Makerspace.com.
Don't forget the dash or you'll get a different makerspace.
Yeah, so you have to have the dash, BK-Makerspace. Anyway, we also want to give a thanks to Project Make It, which is doing our video feed. And what's the Project Make It website?
We don't currently have an active website.
Okay.
You can contact at info@projectmakeit.com. We do
info@projectmakeit.com.
We do system administration and networking security for small and medium businesses.
All right, that's system administration, network security, and video feeds.
Yes.
So, anyway, we just want to thank everybody for helping us out. We wouldn't have an organization without that. Anyway, so without further ado, I'm going to hand it over to George, and he's going to give us an update on the reflow oven, and also talk to us a little bit about a new way of wiring 7-segment LEDs. Take it away.
Alexa, camera. Yeah, go ahead. Not sure. I'll do it. Can you do it? It's hot. You have to loosen the screw balls.
no, 2 months ago,
Yep.
I brought up the subject of maybe working on a reflow controller for doing surface-mounted parts, and decided to go ahead and try it just to see how far I got. And I've gotten pretty far along with it, still waiting for some testing stuff, including solder paste, and it's kind of hard to test without that. But basically, this is the $10 Walmart hot plate, and I've replaced the 3 mounting screws with longer ones. The heating elements are not level, so the saw blade, circular saw blade, would not rest evenly on them. So with the screws, it's about 1/8 of an inch above the heating elements. So that's the active heating unit, and this plugs in to a solid state relay, which switches it on and off. Okay, I got the solid state relay on eBay. This is an American-made solid state relay. American, and it was like $14. But they sell cheap knockoffs on eBay of something called Photech for like $6. And the problem with those is that their ratings, their current ratings, are nonsense. If you open them up, you'll find that something that's rated for 10 milliamp or 10 amps is actually got a 4 amp part in it. So this is a 1,000-watt hot plate. So you're looking basically at 10 amps. You would want to order a 40 amp if you use the Chinese versions, just to kind of have at least a chance of having something that would work. I'd also ordered the heat sink. You see that? And the heat sink, I have found, doesn't even get warm. So I don't think it's really needed. I mean, this doesn't operate for a long period of time, so it probably.
It's a nice heat sink. I mean,
It's a nice heat sink, yes.
you can keep working.
Yeah.
So that's good.
Now, what I've done, the approach I've taken on this is a little bit different from what you'll find on reflow controllers. This is, first of all, this is just an Arduino Nano and 2 7-segment displays, a rotary encoder, a buzzer, and 2 LEDs, and that's really it. And this plugs into a port, and it just switches the solid-state relay on over and varies the duty cycle of the power over a 2-second period. So if you set the duty cycle percentage to 50%, it'll be on for 1 second and off for 1 second, and just repeat that over and over again. Most controllers have feedback from what's being heated up. And I found in the process of working with this that it's very difficult to get a thermocouple attached to whatever you're trying to heat up in a way that gives you accurate measurements. And this is the thermocouple I used. This is I think this sells for $5.50, and it's a thermocouple with its own display, so you don't have to plug it into anything else. It's 26.9 degrees here, Celsius. So what I did with this is to write the sketch in a way that simply goes from a fixed series of duty cycle percentages in order to produce what's as close as possible to the standard temperature profile. To start with leaded solder paste. And so it does that without any feedback, and the idea is if you can get something that works that way, then every time you plug it in, it'll do exactly the same thing, and you don't have to worry about placing the thermocouple correctly. The mass of this, for the thermal mass is pretty hefty, so I think the size of the board probably won't make much difference. But it's just an Arduino sketch. So if you find something that doesn't work, you can go in and change the settings, I mean, it's like 6 or 7 lines of code and just put in what you want. Not having to mess with a thermocouple, and if it works for you, you don't even need one of these. It would be a fairly simple, cheap setup. I mean, you'd need an Arduino, you need the solid state relay, you need the hot plate and the saw blade. You don't really need the 7 segment displays or the rotary encoder if you don't want to mess with them. You just it'll do its thing whether those things are there or not. So for something like maybe $30, you would have a working reflow setup. The other thing about this is it doesn't have to be a hot plate. I mean, if somebody wants to do a toaster oven instead, all the relay does is just switch the power on and off, and so it can be applied to anything. Well, anyway.
How did you choose the duty cycle?
Experimentation. I knew there was going to be a huge lag. If you turn it on 100% and it's 20 seconds before it changes at all. So I mean, that's the kind of thing we're dealing with, and I don't know how. I know PID controllers are supposed to be used for things like this, but with a lag like that, I don't know how it could possibly work. Anyway, I just tried a few things, and over a weekend, finally got something that worked pretty well.
So did you actually do a run of this and get something?
No, I have.
I've got some solder paste here. We can try it.
Here's a test kit. These are like $1, but I don't have any paste, and I'm waiting for paste to come in.
I think I have some.
Okay, well, we can try it.
Because I was supposed to say, the other question I had is, were you thinking about building a sort of a stove box to keep the temperature local?
No.
Affected by air?
The question is whether building a surround for it to keep our air away from it. I haven't done that yet. We could, of course.
Well, wouldn't that make it harder? Because you said that it's having trouble cooling.
Well, here's the thing. One advantage of this setup, this does not cool down fast enough to meet the profile. But if you have some oven mitts or a hot plate, after it's melted, you can simply pick up the saw blade and put it down on something, and then it'll cool off plenty fast enough.
So the actual, the non-attached saw blade is load bearing, essentially.
The saw blade's pretty convenient for that. I don't know yet whether this will work, and I don't know if it makes sense as a way to do things. I mean, I don't know whether the size of the board really matters or not.
As far as like the edges melting first or something like that?
Yeah, or just if there's enough board mass, does that slow down the heating, and prevent it from reaching? But the sketch is written so that you can add any number of profiles without having to rewrite anything. Just add in the next table, and the way it works is you plug it in, you just hit the button on the rotary encoder, and it shifts you to the next profile. And then when you've got the one you want, you do a long press, and it starts it doing its thing, and it just keeps going until it finishes.
Did you upload the sketch to your GitHub?
No, not this one. Not until I know it works. Now you were asking about the 7-segment. Part of this was 2 7-segment displays, and I looked up online and found the way people normally do the multiplexing for these, and that's digit by digit, and it required a resistor on each segment line and transistors on the common cathode lines because the current's too high, and I didn't want to do all of that. So this uses a method, it's multiplexing by segment, and it doesn't require anything but one resistor on each common cathode. And there's even a ancient chip called the CD4017, which can be used to sort of offload the burden of the segment lines onto that chip so you don't use up as many processor pins. And with that method, you're using the number of pins you need is equal to the number of digits you have plus 1, which is pretty modest pin requirement. Anyway, I made a video on that, and I asked John if he wanted to put it on the group's YouTube channel. I don't have a YouTube channel, so I thought it might be good if the open source hardware group had some open source hardware videos, and so anyway, it's there if you want to watch that. And
So you want to? I've got the code up. If you want to walk us through the code on this.
on the 7-segment,
Yeah.
well,
I don't know if it's too hard to walk through, but give us an overview.
I can try. So we start out defining the number of segments, which is 7, of course. Not using the decimal point, and the number of digits, which is 2, and then assign pins to each of the segments and to each of the common cathode pins. I make an array out of the segment pins so I can refer to them by number. So go on down a ways.
Now, why did you choose to do this instead of using, say, a 959 or 595?
Because a 595 takes too many pins to drive. You need a clock, you need a data line, you need, all of that. If you use the 4017, you need 1 pin.
But now you're in charge of updating.
Well, the 4017 enables each segment line one at a time, whether you need anything lit up or not. It just goes through one at a time, and all you have to do is clock it. All of the intelligence is in the common cathode pins because they determine on which digit that segment lights up. So
What about using a shift register?
same thing, you need more pins. Well, that's what the 595 is, right?
Yeah.
So you can use a shift register, you could use 3 to 8. I mean, it's just, all kinds of stuff, but none of them operate on 1 pin.
So one project I saw recently, there's this guy, Sean Hodgins, has a YouTube channel. I think his business is called Idle Hands Development. But he does lots of little electronic projects. And he recently just released a 8-segment display with a decimal that it's chainable. This has a nice little jumper design. You can use a little board and it sort of chains together, and you can have as many as you want. And it uses the chip from the WS28, I think, chips. A set, and those are the ones that drive like the addressable LEDs, like the single LEDs. And what he does is he uses 3 of those chips per segment, so he has 9 total. I think one he doesn't use a LED output on it, and so he has 3 of those chips. So three of those chips is 1 segment, and then it just uses the the same Arduino code you would do for those addressable LED strips. And I think he has a little library in between where you can say, like, this is how many segments it is, and then it says, you know, puts all the calculations in place to send those updates for those 3 chips per board. But he open sourced it and just did his little, like, he didn't do a crowdfunding program, he just released it on his shop, and he got like 1,000 orders for it. So 1,000 little segments or whatever that he has to build or have manufactured or whatever. But it's a similar vein somewhat.
Yeah.
Just different solution.
Well, the main thing is just, you know, if you look up multiplexing 7-segment displays online, you'll get that digit by digit thing with, you know, 7 pins and transistors and all that kind of stuff, and it just doesn't have to be that way, you know. So this is going to be too complicated to go through, I think.
Okay.
First of all, I would have to remember it.
Well, here's the.
Yeah, that's the 4017.
Why don't you just describe the schematic?
Well, you've got the 4017 is driving the segment lines, and this is a 10 decimal output thing, so there are actually 10 outputs, but you only need 7 of them. Actually, in this case, it's showing the decimal being used, so you need 8 of them in this setup. And the 9th one, which is Q8, is tied to the reset, which is active high. So when it goes high, it resets the chip, and so you just start over again. So depending on what you attach the reset line to, there are no extra steps in there. You just take exactly the number you need. The problem is, as I said in the video, is that the initial state of this when it boots up is unpredictable. So instead of assigning a clock processor pin to the reset, you can just feed back the output from Q0 back to the port pin, and then switch your port into input mode and read the value on the output. And you keep clocking and reading until you get Q0 high, and then you're initialized. You're where you need to be. That was the part that took a while on the sketch. I found that you have to digital write to that port pin before you switch it back to output mode. I'm not sure why, but it's just one of the characteristics of the Atmega processor. So you got, you know, 2 digits here, and you've got 3 pins driving it. 1 for each digit on the common cathode, and 1 pin for the 4017. It does automatically what you want it to do anyway, and so that's pretty handy. Anyway, next time, or maybe later this evening, we'll have some test results on the hot plate and see whether that's going to work. And then I was thinking maybe, you know, if it does work, we could have the Tosh reflow controller. Who knows?
So do you want to try to plug that thing in?
Well, we can, but it's going to take a little prep to get the test ready, I think.
All right. Well, we can shut off the feed, and we can say goodbye to YouTube, and then we can go do it.
Okay.
All right. Well, I'll give a.
Oh, we wanted to set the time for the next meeting.
We already did. All right, so we're gonna the rest of the meeting we're just gonna do local. We're gonna try out George's controller and give it an initial test run and see how it goes. Next month is February. I think it was 20th. Let me double check. Yes, February 20th, and I'm going to talk about transistors and kind of the theory and practice of transistors, and we will. And if anyone has any project updates, feel free to bring your project, and then we'll have that meeting live streamed, or you can come down to BK Makerspace and check it out. So, all right, you all have a good evening, YouTube, and we'll see you next month.